Hi guys, this is part 3 of our logical beetles lesson. Let's recap what we already know about Boolean logic. Boolean logic can only return one of two values, true or false. When we start using if statements in our code, they function like logic gates, and depending on the conditions, will give a true or false output. We're going to be concerned mostly with conditional and comparative Booleans. Conditional Booleans only deal with one condition. Comparative Booleans check the relationship between two or more conditions. Let's see what this looks like if we're working in Scratch. First, I'm going to go find an if statement in the control drawer. See how the if statement will only take a hexagonal block? All of the Boolean blocks in Scratch are going to be this shape. The conditional Boolean blocks live in the sensing drawer. Here are your 5 conditional Boolean options. You've got touching, touching color, color is touching, key pressed, and mouse down. Remember, with the conditional Boolean, all you need is one condition. So these blocks kind of work on their own. You can just throw them directly into the if statement. The comparative Boolean blocks all live in the operators drawer, and there's actually 6 of these. You've got less than, equal to, greater than, and then you guys are probably familiar with these. You've got and, or, and not. Unlike the conditional blocks, the comparative blocks don't specify the conditions yet. See how they also have hexagonal spots here for the conditions? You could put an and block in here, but the code wouldn't know what to do because you haven't specified the conditions yet, just that you want to compare 2 of them. All of these Boolean blocks will allow the if statement to return either true or false. If the condition is true, then the program will continue reading the code inside of the if statement. So, for example, I could put this conditional in there, and then if it returned true, then my sprite would move 10 steps. One cool feature in Scratch is that you can actually put conditional Booleans inside of the comparative Booleans. So, for example, I could grab touching color green and mouse down and compare 2 conditional Booleans in one comparative Boolean. I'd like us to look a little bit more closely at the comparative Booleans that look like our logic gates. Those would be and, or, and not. Maybe you've noticed that some of your logic gates seem to be missing from these Boolean blocks, but we can actually build all of your missing logic gates just from these 3. So I'm going to move these guys over, and we're going to see what we can make. So the first one I'm going to make is going to be a NAND. So I'm going to take a not block and an and block and just stick it right in there. And I'm going to do the same thing for the NOR. So I'm going to take a not and an or and put it right in there. Creating an exclusive OR is going to take a little bit more building. We're actually going to start the exclusive OR with an AND. Then in the first condition spot, we're going to put an OR. And in the second, we're actually going to put a NAND gate. The 2 conditions that you're testing would go here, and then be repeated in your NAND block. What you're telling the program is that it could be condition 1 or condition 2 and not condition 1 and condition 2. There's a reason that this one was the hardest to make on the proto boards. An exclusive OR is really 3 different gates. I'm going to grab some code that I've already built from my Scratch backpack and drag it into this program. The repeat until block is a little bit different than our if statements, but I wanted to show you that they also use hexagonal Booleans to function. So in my code, I'm using a repeat until block to tell the T-Rex, hey, until you hit the Stegosaurus, keep moving. Then we move down into my if statement. My if statement is actually checking the relationship between 2 different conditions. The first condition is touching dinosaur 3, which is the Stegosaurus, and the second condition is score is equal to 5. I'm using the comparative Boolean and to check the relationship between them. So if the T-Rex is touching the Stegosaurus and the score is equal to 5, those are both true, then we're good. The T-Rex is going to say yum. If the T-Rex is just touching the Stegosaurus or is only at a score of 4, then one of these would be true and the other would be false, and it would return false. So it would say nothing. I want you to play around a little bit with both the conditional and the comparative Booleans. Both are going to come into play when we start building our BeetleBots. But for now, just give it a try. Let's see what you can make.